So, in this video I'm going to talk about how you can solve simultaneous linear equations by substitution. Setting up systems of equations is quite a useful technique, especially later on in physics. In any case, when you're given two variables, unknown variables, it's certainly a technique that comes in handy. And so, for question 1, you're given x plus 3y equals 11, and we're given 4x minus 7y equals 6. So these are the equations for our two lines. We need to find where they intersect, and so indeed we're going to set up a system of equations, and we're going to solve simultaneously, in other words. And so they explicitly want us to do so by substitution. And so what immediately stands out is we can isolate this x term in the top equation by subtracting 3y from both sides. And so what we end up with is x. Actually, I'll just write it this way. What we end up with is x equals 11 minus 3y. And I just box that off. So now we know what x equals. It's 11 minus 3y. We can substitute this value for x into our second equation. If this is equation 1 and this is equation 2, we can substitute this into equation 2, and what we then get is 4 times 11 minus 3y minus 7y equals 6. And so by doing this we can find the value for y. So 4 times 11 is 44. 4 times minus 3, negative 3, that's going to be negative 12. So 44 minus 12y minus 7y equals 6. This is minus 12y minus 7y is going to give us minus 19. Minus 19y. And so actually what we can do is we can add 19y to both sides and subtract 6 from both sides. So what we end up with is 19y equals, and 44 minus 6 is going to be 38. So we have 19y equals 38. Now we just divide by 19 from both sides, and of course that's just going to give us 2. So we have now y equals 2. And now we can take this value for y and we can substitute it back into the very first equation, and where we know x equals 11 minus 3y, and so I will just write that up here. So now we know that x equals, and so it's 11 minus 3 times 2. 3 times 2 is 6, so x is going to equal 11 minus 6, which is going to be 5. So that's what x equals, is 5. So therefore x equals 5. And these x equals 5, y equals 2. That is the point of intersection of these two lines. Right, let's work on another example. I think this one will be okay. It looks interesting. We're given 3x minus y equals 7. We're given 10x plus 3y equals negative 2. So we can isolate this y term in the first equation. If this is equation 1 and this is equation 2, we can just add y to both sides and subtract 7 from both sides. And so what that's going to give us is y equals 3x minus 7. And now we know y equals 3x minus 7, so we can substitute this into equation 2, in which case we have 10x plus 3 times y, which is 3x minus 7, and all that is set to equal negative 2. And so 3 times 3 is 9, so we're going to have a 9x and 3 times 7 is 21, so 9x minus 21. 3 times negative 7. And we can simplify all of this. So what we end up with is 19x. 10x plus 9x is going to be 19x. And I'll just write it down here, 19x. And we can add 21 to both sides, in which case we're going to have 19. So 19x is going to equal 19, and then you just divide by 19, and we are going to end up with x equals 1. So now that we have the value for x, we can just substitute it back into our equation for y, into equation 1, I should say, which is a line, and I will write that here. So y equals 3x minus 7, so instead it's going to be y equals 3. We know x equals 1, so 3 times 1 minus 7, and 3 times 1 of course is just 3. 3 minus 7 is going to be negative 4. So it's going to equal negative 4, so therefore y equals negative 4. And therefore also one could say that, or should note that at x equals 1 and y equals negative 4, that is the precise point of intersection of these two lines. Have time for one more. So let's just, this one looks like a good example. So we've got 2y equals 2x minus 3. It's going to be our first equation. We've got 3y equals x minus 1. So it's equation 1, it's equation 2, and so we can very easily isolate x in equation 2. So that's what I'm going to do, and basically we just need to add 1 to both sides. It's quite easy, so we're going to have 3y plus 1 equals x. So x equals 3y plus 1. So now we know the value for x. Well, we know that at least it equals 3y plus 1, so you can substitute that back into equation 1, which I'll write up here. And so we have 2y equals 2 times 3y plus 1 minus 3. And 2 times 3 is 6y, and actually it's getting a little bit cramped, so I'll just write a new over here. So then we have 2y equals, well, 2 times 3y is 6y, and then 2 times 1 is 2. So it's going to be 6y plus 2 minus 3. 2 minus 3 is negative 1, and so therefore we have 6y minus 1, and we can rearrange this a little bit by subtracting 2y from both sides and adding 1 from both sides, just make it a little bit more neat and tidy. So if we subtract 2y, we're going to end up with 4y, and we add 1 from both sides, we're going to have 4y equals 1. And from there we can just divide by 4 on both sides, so y equals 1/4, which is okay. And now we have we can just substitute this value of y back into equation 1, wherein we can solve for x, and it's already neatly prepared for us, where we have x equals 3, y, well, we know y is 1/4 plus 1, and 3 times 1/4 is going to be 3/4, 3/4, and 3/4, and if we add 1, that's going to be well, that would be 4, so 7/4, so x equals 7/4.